Okay, today's lesson is on overlapping triangles. We have several targets. I can recognize overlapping triangles in a diagram. So in other words, you need to be able to see them when you see your diagram, realize that they're there. I can determine which pair of overlapping triangles will help reach the conclusion that you're looking for. And then I can prove overlapping triangles are congruent. Okay. So recognizing overlapping triangles. I've given you a picture here and I've marked a whole bunch of congruences, and so we're going to try to name all the pairs of triangles that are congruent. So usually the first ones that the students pick out are these purple ones right here, and those would definitely be congruent by side, side, side. That would be triangle, let's say PYR would be congruent to triangle QZR. All right. Now we're going to try to look at the overlapping ones. So let me start in green. Should be looking at this top left triangle, and then it overlaps with this top right triangle. So if you're having trouble seeing that, I'm going to say that's triangle PXZ, and that would be congruent to QXY. Right? They each would have this side congruent to this side using addition. They would have this side congruent to this side using addition. And then these short sides, this is part of this triangle on the left, and this XY is part of this triangle on the right. So we'd also have side, side, side. And then the last two that are hidden in here are similar, but they're here at the bottom. So it's that triangle, which I could call triangle PYQ. And then this one to the right, right? So if I did PYQ, I'd have to do QZP. All right, they share this side, that would be reflexive. These two pieces are congruent, and then these diagonal pieces would be congruent by addition. Okay, the ones that appear to be overlapping are obviously the green ones and the orange ones. That's what we're going to be focused on today. So we're going to see this diagram a lot. So if you have some colors, go ahead and mark up in your diagram the two that we talked about. So we talked about these top two that overlap, which were the green ones. And then we talked about the bottom ones that overlapped. These were these orange ones. Okay. In overlapping triangles, they always share something. So we kind of mentioned it when we talked about these orange ones. We said they both have this side, and we could say it's congruent to itself by reflexive. So here, they share this side right here. In this diagram up here, it's a little bit harder to see. They don't actually share a side, but these two triangles actually share this angle right here. That angle is in both this one on the left and this one on the right. So overlapping triangles will share an angle or a side. To use these parts in proving triangles congruent, we would then use the reflexive property, remembering that it works for both angles and sides. Okay, they share an angle or a side. All right, let's see how this looks in some problems. All right, so name all pairs of overlapping triangles in each figure that appear to be congruent. Just appear, I didn't give you any congruence markers. So perhaps you could say this triangle right here would be congruent to this triangle right here. Those wouldn't necessarily be overlapping, but if I did triangle ADE, and hopefully you can see it's overlapping with triangle here BED, that would be this triangle and then that triangle. Those would be a pair of overlapping triangles. I could also do that for the top two. So I could do triangle ADB, and then it would be overlapping with this one right here. So if I said ADB, I'd have to say BEA. All right, so either the two overlapping where they overlap on top, or the two overlapping on the bottom. In this diagram, right, hopefully you can see several overlapping triangles, right? One you might see, right, FEC right here, looks like it might be congruent to this guy right here. So we could say triangle FEC is overlapping with CDF. Those appear to be congruent. We could also try FED, this guy right here, and then triangle EDC right in there. So maybe I should do those in another color here. Let's do that in red. This triangle FED is overlapping with triangle EDC. All right, if you look closely, I think you might see another one. If we look at triangle FDC, this guy right here, which we already looked at with the orange, if we look at triangle FDC, look at triangle ECB, I think you might see it's congruent with that one as well. So maybe that's one we can list too. FDC congruent to triangle ECB. So again, part of it is really trying to be able to look at these diagrams and pick information out. Now here again, I'm not marking any congruences, so we wouldn't know for sure, just what looks to be. Here there might be several triangles that you might say congruent. You might say this little triangle looks congruent to this one, but again, we're only looking for overlapping. So what I'm trying to get you to see here is that this blue triangle, right, is overlapping with this purple triangle, and those look congruent. So that's a little different way to overlap. We could say triangle EDB is congruent to triangle CDA. And that's a little bit different kind of picture from what we've seen. All right, so let's get some practice actually doing this in proofs. If you don't have colored markers handy, this is a great section to have them for so that you can really pick the triangles out. AC is congruent to AB. Let's mark that. AC, AB. And then AE is congruent to AD. AE and AD. We're trying to get CE, I'm going to put it as a dotted line here, and BD. So if you think about what we did on the last page, I think these were the green triangles, right? Do you see these overlapping ones at the top? This guy and this guy. In fact, let me bring that page for a minute. So if you think about what we did on the front, it was those green triangles. And in fact, if you slide it down, we had them highlighted right here. Look at what we said those two triangles share. We said they share that angle right there. So I think that could be helpful to us in our problem. So let's look, right? I think those two should share angle A. So I'm going to mark angle A congruent to angle A by reflexive. And then I'm going to try to look just at one of the triangles. So if I cover this one up and I just look at that one green triangle, I see that I have a side, that's this marking, and in between this side and this side, I have this angle. So I actually have side, angle, side. So I'm going to say triangle CAE is congruent to triangle BAD, making sure I correspond correctly, by side, angle, side. And then CE and BD are corresponding parts. So again, if triangles are congruent, then their corresponding parts are congruent. Oops, I'm off the screen again. All right, let's look at example 3. Let's mark what we have here. FH congruent to MJ. That's this whole segment. and MJ. G is a midpoint of FH, and K is a midpoint of MJ. So I have two midpoints. So I'm thinking of multiplication or division, especially if I have the bigs or the littles, and I realize I have the bigs. So I'm thinking I can probably use division. I have one more piece of given. GHJ congruent to KJH. GHJ, this entire bottom angle, congruent to KJH, this entire bottom angle. So I hope you can see we're looking at some angles or some triangles here at the bottom that look pretty appealing. I see this triangle, that orange one, which overlaps with this orange one over here. So I'm looking at those. If I just focus on one of them so far, if I hide that, I'm hiding too much here, I have an angle, right? And that's it. But remember, I had a midpoint and I had a big. So I think I can divide to get this little piece right here, and here take this big and divide to get this little piece right here, and that'll give me a second piece of those triangles. So KJ is congruent to GH by if segments congruent, then like divisions congruent. Now I'm closer. Let's go back and just look at one triangle. Sometimes that really helps to see what parts you have when they're overlapping. I have an angle and I have a side. I'm missing one more piece, right? Now remember, overlapping triangles often share something, and hopefully you can see that they share this side HJ. It's a part of both triangles. So I'm going to mark it, and I'm going to get it congruent to itself by reflexive, because again it is in each triangle. Then I believe if I go back here, I have side, angle, side on the two triangles. So triangle GHJ congruent to triangle KJH. We said that was side, angle, side, and now these are corresponding parts. GJ is for the triangle on the left, and HK is for the triangle on the right. So GJ congruent to HK if triangles are congruent, then their corresponding parts are congruent. And I'm sorry, I'm off the screen again, so let me put that up. I've been talking and not showing you. So again, we use division to take these whole segments and divide to get KJ congruent to GH. That's one piece. The angles were in the given. We can see that the two orange triangles share HJ, so we did that by reflexive. And then I have side, angle, side, and then on the triangle on the left, side, angle, side. And then these two pieces are corresponding parts, these two diagonals. All right, one last proof, and it's a doozy. So this will be by far the longest one we've done, but it's a good one, so I want you to see it, to see where we can take this. We're going to bring in several ideas that we've been using lately. NR congruent to NV. All right, NR and NV. P and Q are midpoints. All right, so if you stop right there, you should realize we can do something just with that bit of information. I have two midpoints and I have the bigs congruent. So I should be able to get the smalls congruent. So I'm going to leave some space for the rest of the given, and I'm going to jump to that. The question is, which smalls do I want? Well, if I'm looking at triangles, I definitely see some overlapping triangles down here. So it looks like I might want PR and QV. But I don't really know, so I'm also going to say PN and NQ. I don't know which ones I want, so I'm just going to say they're all congruent. I'm going to say if segments are congruent, then like divisions are congruent. All right, what else do I have in the given? I have angle R congruent to angle V. and I have px congruent to qx. Px congruent to qx. All right, so in one of the last units we had, or one of the last in chapter 3, we had an auxiliary statement, and that's really going to be helpful here. I'm going to connect point N and point X, and I hope you see that by doing that, I've created two triangles that I think I can get congruent. So draw NX auxiliary. Then if I do a little reflexive on NX, let's mark that one up with something different, I can get that pair of triangles congruent. NPX congruent to NQX. Side, side, side. And you might say, well, I don't really know why I need those because I'm trying to get XS and XT. Those are the pieces I need. So it doesn't appear that those seem to be helpful. Well, they're going to be in a minute because our next focus is going to be on these two green kind of overlapping triangles. I think you can see if we have certain parts of them already. I have this segment, and I have this angle and this angle. So the question is, what other piece can I get? I cannot do reflexive because they don't share a whole side. They share a piece of a side, which is ST, but not an entire side. So what I have to do to get a third piece is to use something from these two congruent triangles. I'm going to say that these two angles are corresponding parts, and I want you to think about why I'm picking those as we're writing them. Angle NPX congruent to angle NQX by if triangles congruent, then corresponding parts are congruent. So how do these two angles help me get something in the green ones? Hopefully you realize that they are supplementary to these two angles. So I'm going to start my three-step process. I'm going to say angle NPR and angle NQV are straight angles. That's assumed. My second step is to say the supplementary. So angle NPX is sup to angle RPX. And angle NQX is sup to angle, how did I say this here, VQX. And that, of course, is if angles add to 180, then they are sup. Now my third step, right, I put them in the box. I know NPX and NQX, these two right here, are congruent from step 6. So therefore angle RPX is congruent to angle VQX by if angles sup to congruent angles, then congruent. Let's mark those in the diagram. I now have this angle congruent to this angle. And if you take back a look at our green triangles, I think we can now say those green triangles are congruent. So I can say triangle PRT is congruent to triangle QVS. And that would be by angle, side, angle, angle, side, angle. Now the question is, how are those going to help me get XS and XT? This is not a corresponding part of the green triangle. It's part of a side, but it's not an entire side, so I can't just say corresponding parts. However, I can get this whole side QS congruent to this whole side PT. Those are corresponding parts. So PT congruent to QS if triangles congruent, then corresponding parts congruent. So let me use a color for those. So I just got this whole segment congruent to this whole segment. It's kind of a crazy diagram, but hopefully you can see we have overlap. I have this whole orange segment, and I have PX. And I have this whole orange segment, and I have QX. So now you know we should be able to subtract to get XS congruent to XT by if congruent segments are subtracted from congruent segs, then the differences are congruent. And you just did a 12-step proof. Good job.